Hello everybody, I hope that you all are doing well and are rested and are ready for this test coming up. If not, hopefully this study guide will help. What I'm going to do is I'm going to go over some things and emphasize some things that you need to know. If you need to pause the video, that's fine. Pause it as much as you like. Ask me questions if you have any. I will be glad to help you. So some things that you need to know. You need to know, for example, you see kg, that's kilograms. You just need to know that that is the mass. Okay, mass in a formula is M, and mass has the same letter as meters, but you've got to remember that mass is when it's in a formula. The units are what's next to a number, so like 5 kilograms. Okay, velocity is always meters per second. The acceleration is meters per second squared. Now this square does not mean you square the whole number. It means it's just connected to the seconds. It's just part of the seconds. You don't have to do anything with that square. Distance and height, those are meters. Okay, so this M looks like that M, but it's different because this is usually with a number, and this would be meters. Okay, the energy is measured with J, or joules. Okay, so let's take a look at some problems. For example, the first one says, what's the kinetic energy? That gets a question mark. Kilograms, that is the mass. And then here I've got meters per second, so that has got to be the speed. We are using the V for velocity, but speed and velocity have the same number. Okay, so as we work it out, you're going to put all of the data that you're given. So you pull these numbers out and label them with the letters that are going to be used in the formula. Tell me what formula you're going to use, and then when you solve it, instead of the M, you're going to actually put the mass. Instead of V, you're actually going to put this. So this will tell you what to do with the numbers. When you see a square, especially at the end of a formula, always go backwards. So I'm going to solve this going backwards. So I'm going to take 6.3 and square it. Or you can just take 6.3 times 6.3. That is squaring that number. Then I'm going to take the answer and I'm going to multiply it by 33. And then when you have a fraction, you're multiplying by the 1 and dividing by the 2. But you know that multiplying by 1, you don't have to. So this number times 33 divided by 2, and that should give you the correct answer. Okay, let's try another one. Okay, so here it says, what is the potential energy? So that is going to get my question mark. Here, this is kilograms. That has to be mass. And this is not meters per second. It is not velocity. So don't get tricked into that. Really take a look. Meters is your distance or your height. So when I go looking for formulas, I'm going to look for one that has potential energy, but it also has height, because there is no velocity. Okay, so what I'm going to do is write out my numbers. I'm going to put my formula, because this has height, has potential energy, I know the mass, and I know G because it's right up here. And also just, you can memorize it or I'll give it to you on the test. All of these will be on the test. Now, on this, when we are working out problems in detail, do not round that number. Sometimes people round it to a 10, which is good for some types of problems if you're trying to do them fast. Here, you want the actual number. Okay, so I'm going to take my mass, which is 12. I'm going to take G, and then I'm going to take the 8.5. And I'm going to multiply all these together. So when they're together, that means multiply. And so this would be your final answer. Okay, let's take a look at number 3. Okay, I've got calculate the mass. So I need mass. Mass is, I don't know. Meters, don't confuse that with mass. This is meters, that is height. And this says energy. It does not say potential or kinetic, so we're just going to say E. We'll figure that out later. Okay, so when I work out my problem, I'm going to put the data. I'm going to choose the formula that has mass by itself, but also has H. So that one is this one right here. Putting in the numbers, I see that I'm going to have to multiply G times H. I'm going to do that. Then I'm going to put this number in the calculator first, and I'm going to say divide by the answer here, and I should get this. Okay, the fourth problem, calculate the mass. So mass, I'm looking for that. Here it is moving at this, meters per second, that is velocity. And this one is energy. Okay, so I need a formula that has energy, but it also has velocity. Okay, so it could be either potential or kinetic, but the one that has velocity is kinetic. Now, I have the kinetic energy. I don't need to use this formula. I want the one with mass by itself. This is the formula I want to use. So that 2 just means I'm going to multiply 2 times whatever the kinetic energy is, which is this. I'm going to take the velocity and square it. That means take it by itself, times it by itself. Okay, so here, 2 times this, and I'm going to write my answer right here just to have it. That's a habit of mine. I like to know where my numbers are. Then I'm going to take velocity, which is here, and I'm going to square it. So when I square this, I'll take 3.69 times 3.69, or hit the square button on your calculator. Okay, so I'm going to take this answer, and I'm going to divide this by that. So this goes in the calculator first. Top number goes in the calculator first, and there's your final answer. All right, so let's go over some other things. Okay, so here it says if you're walking to the top of the hill, your potential energy is increasing. Yes, the farther you away go from ground level, you will get higher potential energy. Okay, so total is 100, potential is 30, so how much is kinetic? Well, so the sum of kinetic and potential is the total energy or mechanical energy, so I'm just subtracting. Okay, here again, I'm going to do the same thing. I've gotten different numbers, but I'm going to take the total, subtract out the kinetic, and that leaves me with potential. Okay, so this goes to this diagram. So you've got 3 different shapes here. So if each of these falls off, yeah, you got an earthquake, falls off, which one is going to have more potential energy before it falls? Well, this one's higher up. So the rectangle has to have the higher energy. Okay, so if gravity is 3 times that on Earth, that means that the weight is going to be 3 times more for that person. So they are going to have 3 times more the potential energy that they would have normally. Okay, here I've got, it says, a baseball traveling at 15 meters per second was deflected by a wall. Okay, so here comes the ball, and it hits this wall, and it deviates, and it slows down. So it was going at 15 meters per second, now it's going at 10 meters per second, and they want to know how much energy it transferred or lost to the wall. So I need to do before and after. So I'm going to use the formula here, our old kinetic energy formula. I'm going to do before. So I take 1/2 of 10 kilograms, because it says 10 kilograms here. It says it was traveling at 15 meters per second. I'm going to square that number, multiply it by 10, and multiply it by 2. So I would get this. Okay, so let's do it afterwards. Afterwards, we got the same setup, same numbers, 10 kilograms, but now I have 10 meters per second. And I'm going to square that number. I get 100. 10 times 10 is 100, times 10, divided by 2. Okay, so this is how much it had before, that after. Subtract them, and you would get this for the amount that was transferred to the wall. Okay, so here I've got a complicated problem. Actually, it's not so complicated, it's just tedious. So I want you to get enough practice where you really understand how to do this. Okay, mechanical energy is equal to potential plus kinetic. And the mechanical energy is the same for all 3 positions. So mechanical, 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 all 3 the same. So once I figure this out, okay, so how do I figure this out? I'm going to take kinetic energy because I have mass and velocity. I'm going to take 60 times 8. I have to square the 8. 8 times 8 is 64. times 60 divided by 2, that gives me this answer here. That is the kinetic energy. I know that because potential has to be 0. He is on the ground. He's skating on the ground. So he is moving, but he is at 0 potential. Okay, so let's take the second problem. Okay, so now he's skated up the ramp and he's gone 1 meter. So I need to figure that out. I know the ME because it's going to be the same. Okay, I don't know, I haven't calculated this yet. I need to calculate the potential energy. So I'm going to take mass is 60. The G in this case, we're going to round it by 10. If you're working out problems on the test, sometimes it's just easier to round it to 10. Makes your calculations easier because you don't have to show your work. I'm just showing you here how I got them. Okay, so that would be 600. I'm going to subtract these two, and I'm going to get the kinetic energy. On the third one, I don't think on your copy it came out, but it should say 3 meters here. I'm going to eliminate these, just make it a little more simple. Let's not get too involved. Okay, so ME, that's the same for all, so I know what that is. I don't know the kinetic energy, but I can figure out what the potential energy is. So I have 3. I have that he's 60 kilograms. So I'm going to take the mass times 10. I'm just going to round it. You don't have to round it if you don't want to. I'm just trying to give you a little easier way to do these. So 60 times 10 instead of 9.81 times 3 meters. Multiply that, I get 1800. That's what I put here. So then I would have this blank, so I'm going to subtract these two like I did down here, and I get 120 joules. And that makes sense. He's really high up, so he should have a lot of potential energy and not much kinetic energy. Eventually he'll come to a stop, he'll have 0 kinetic energy, and then he'll start coming back down the ramp. Okay, I'm going to pause this here, and I am going to do the last half on the, another video. I hope this helped.